Now I'll just hand over the mic to Adish. He's been working with Physics Wala and a data engineer 3 at there. So uh, we got into a call with them, and they told us that OLake is kind of a rising hope for them because they used to use Debezium and faced a lot of problems with those infrastructure. So Adish, over to you. Feel free to educate us on how OLake helped you and what are your use cases with OLake and things like that. So yeah.
Hey, thanks, Priyansh, for introduction and for briefing the progress of OLake over the past few months. And like I've been in touch with Shubham from like it's around 3-4 months now, right? When you started, and we have shared a lot of problem statements, and happy to see that OLake is now running in production, and we have catered a lot of use cases that we have discussed from back then. So I'll just take over the screen. Hey, Rohan, you too. Okay. So let me know once my screen is visible. I hope the screen is visible.
Yes.
So this is something about the collaboration that we have with OLake and Physics Wala. So we'll be covering a few things. First, we'll move to the data infrastructure and the journey that we have in Physics Wala. Then we'll move on to how we are using Debezium for CDC and for ingestion from several sources. We have Mongo and SQL Server majorly. Then we'll move on to the challenges that we have faced with Debezium. Then back to the topic of OLake now, like how OLake is solving our problem and how they have catered the challenges that we have faced with Debezium, and they are very interesting features in OLake that actually resolves most of our problem that we are facing in production as of now. So this is the brief content that we'll be covering. So like just to give like set a context, like going back 2 years in Physics Wala, we used to have a data warehouse sort of uh, architecture where we are dumping everything into Redshift. There we were building some models, or you can call it mat views and views on top of Redshift. But we faced a lot of issues there because Redshift with Redshift we usually have slow bulk loads. Then uh, we don't have the capability for real-time ingestion as Redshift does not seamlessly supports real-time writes, right? Then we have query performance issue when we started to scale our system in Redshift. So these are some like scale and cost, and again the performance related challenges that we faced in Redshift. Then we actually migrated everything to Lakehouse architecture, where we have actually decoupled the storage and compute part completely. So everything now resides on S3, like most of our data. So this is the high level architecture of how we are catering the data use cases at Physics Wala. So if you see our major use cases, sorry, is there someone joined or? Okay.
No,
Yep.
Disha was just sharing some docs with the
Uh,
community.
sure. So, yep. So I was just going through the high-level architecture of how we are doing things in Physics Wala. So we have our major sources in Mongo and uh, Kafka majorly. So Mongo plus Kafka combined to around like 90% of our data that we have in Physics Wala. Then we have other sources like MySQL, Postgre, Google Sheets, and then there are some sources that includes SQL Server as well. So just for the ingestion layer, we use a mix of open source in-house and some paid services for our tools that we are having in Physics Wala. So right now, we are leveraging Spark for both ingestion and processing of data across all the layers that we have here. So if you can see, we have bronze, silver, and gold. This is the medallion architecture that is also common in Databricks ecosystem, but this is completely built in-house at Physics Wala. So in bronze layer, we usually dump the raw data without any transformation and anything. This is just what we have read and we have dumped it here. And then we again have Spark jobs. So that these are both batch and stream jobs that gets the data from bronze and dumps it into silver. So in silver, we curate the data a bit, apply some transformations, maybe data quality checks. Then we have some auditing mechanism, which gives us insights on how many events are ingested. If there is any drop, then if there are any thresholds or where we can actually look into, right? Then the gold is mostly reserved for analytical purposes. So we have data models, mat views, and views inside gold table. So mostly exploitation layer restricted to silver. And then again, for analytics and downstream consumers, you have the gold layer. If you see, we have mostly used Airbyte, Spark, and iceberg. So these are mostly open source tech that we are using right now. On top of that, we have some in-house tools that we have built. So we have dataset API. It's, I think, the small part here. So dataset API. So this is basically the governing layer on top of everything. So here we stores the source and destination metadata. So this is basically the dataset onboarding part where we onboard the dataset uh, via API. So this contains, let's say we are onboarding a Mongo dataset. So information regarding Mongo and like which Mongo, which cluster, which collection, and the information regarding the destination. So if we need iceberg as a destination, then we'll have to put iceberg. Then in what table do we need this data? So these are the things that we can mention in dataset API. Obviously, the partition and these low-level information can also go in, and rest of the thing can be taken care of uh, by the central data platform that we have. So these are different tools that you see in this HLD, but these are all integrated in one place. So we have a framework called CDP. We call it Central Data Platform. So all the tools that you see in this box are integrated tightly, and they can actually fetch the data and communicate with each other. With Spark, so gets the data from dataset API. It learns that this is the destination, this is the source, and we'll have to send this data to this layer. So this is how the complete infra is working as of now. Then we are exposing, as I mentioned, the exploration layer resides on silver, and then we have the downstream consumers on gold. So this data is exposed on both Redshift and Trino. If there is any use case in Redshift, mostly it is exposed to Trino. Trino is again a query engine that we are using. One more thing that we have uh, incorporated here is that we completely use the shared resources via Kubernetes. So all the applications that are deployed uh, are on Kubernetes. So for Spark, Airbyte, Airflow, Open Metadata, Hive Metastore. So everything is on Kubernetes, and they are sharing resources. So we are actually saving a lot of cost in like in terms of, and in terms of performance. We are also leveraging Kubernetes scaling capabilities. It's like container based, and we scale up containers as and when we want. So this is the high level overview of central data platform that we have. Then we have another in-house tool that we call Lagoon. So Lagoon is basically the scheduler that works or orchestrate all the parts of this diagram that we are seeing here. So this is completely config driven sort of framework. We will be passing some configuration like some YAML files, which tells which layer has to be populated with which data, what it should be the schedule interval and all. So everything goes inside this rapid scheduler part. It passes those YAML files and generates Airflow DAG for us. So we don't have to manually go and write Airflow code for every data set and schedule it. So Lagoon takes care of that. Uh, it also interacts with the dataset API that I've mentioned here. So it basically fetches all the information from there and schedules our DAX accordingly. Moving on to the Debezium part. So as I've already mentioned, like most of our data resides in Mongo, and it's always better to read oplogs rather than directly querying collection. It has its own caveats. So we land up on Debezium to cater our use case. So Debezium obviously comes in three flavors. Two are mentioned here, which are widely used. So one is with as a connector in Kafka Connect, so which is what this diagram shows. So we can have multiple connectors in Kafka Connect, listening to a particular database or maybe the deployment in MongoDB, and it streams the data directly into Kafka. The other version that Debezium has is a Debezium server. So there we have a standalone kind of deployment of Debezium, where we can deploy a container of Debezium, which again does the same job, tracks a particular deployment, and streams it into Kafka. With Debezium server, we have one more benefit is that we have multiple uh, options of dumping data. Like apart from Kafka, we can use Google PubSub and all. So this is how Debezium would work in our scenario. We are again deploying this thing on Kubernetes and have a container for each of our deployment. Sorry. Yep. So there are some challenges that we faced with Debezium, like over the past, we can say 1.5 year. So one thing is like complex schema evolution, because we are actually consuming a lot from MongoDB, and by nature MongoDB is schemaless, and there are a lot of use cases where the schema is schema evolves, and we don't get to know if there is any new fields gets added. We have to write a lot of custom logic to track those changes and um, rebuild our downstream tables. So that is one part. Although Debezium has this capability to connect with schema registry, but again, for that we'll have to write a lot of custom logic to handle that changes, and it again has a lot of caveats there as well. With Debezium, we cannot directly ingest our data into a data lake or a lake house, because it works in a way like it is tightly coupled to a message broker system, where we have to have either Kafka or some message broker in place, so that the events can be streamed to that uh, message broker, right? Then we have incremental snapshot problem. So although Debezium has the support of incremental snapshot, we have to have a separate setup for that. So with Debezium, they have a concept called signaling. So if there is a deployment running, we'll have to set up some signaling thing in the production, so that we can signal the deployment to have the incremental snapshots. Again, as I mentioned, Kafka is a must here. Full loads are especially very slow in Debezium if we have some collection with over, let's say, 10 or 20 million of data. So the like full load takes a lot of time to complete and then start its CDC part. Uh, then there is one more issue of handling heterogeneous arrays with SMT. So with heterogeneous array, I mean like Debezium is a Java-based tool, and the arrays that we define in Java has to has like the same data types in them. So that is the limitation in Debezium. We'll have to convert those array into objects or map to accommodate the uh, Mongo schema, right? So this is again a problem for us, as we have to uh, change back these objects back to array for downstream consumers and all. And again, a custom logic has to be in place for this. Uh, there is no resume option in full load. If for some reason our full load fails at some point, there is no resume option that we can have. Uh, Okay, the last one, I think this is copied here, but I'll just walk you through the last one. So there is one more issue with Debezium, is that by nature, Debezium works in a streaming way. If we need some batch jobs, so we don't need the complete CDC, we just need to ingest data from Mongo at a particular interval of time. So Debezium is not made to work in that way. We'll have to manually stop the Debezium job, then restart it again. So this is how we'll have to have a workaround for that, but there is no out of the box support for batch jobs. So that is one more challenge that we have with Debezium. So if we are using Debezium, we'll be streaming the changes which may be needed at a particular interval of time. So there comes OLake again. Like we discussed these challenges with OLake team a couple of months back, and they have actually catered a lot of uh, challenges that we have faced. And as of features in OLake, we have almost overcame all the things that I have discussed, be it schema evolution, and also I'll be discussing the some features that actually we are leveraging from OLake. There may be more, because even I have not explored OLake fully. So uh, for schema evolution, so OLake actually simplified the schema evolution. Whatever changes that we have, new columns, new keys, and complex types, so everything is taken care of OLake without any need of uh, like manual intervention. We just have to set a property called normalization from false to true, and it takes care of that. Then there is a direct ingestion from source to iceberg. So this is the idea of OLake. Maybe they'll be adding the feature in the future for Kafka and other message brokers as well. But right now, this is actually solving a lot of problems for us, that it directly ingests data from source to iceberg, which is our lakehouse format that we are using right now. Full load capability is configurable. We can have either full load or CDC events in our iceberg tables. Um, then there is zero dependency on Kafka that has already been discussed. Handles complex data types. So uh, OLake provides this functionality of converting this complex type that we have discussed, that in Debezium we have to convert it into map type. So OLake sends these complex type directly as a string in our downstream system, which we can handle later on, which is a big time saver for us. Uh, then this is a very good feature of fast and resumable full load. So the full loads are actually very fast in OLake, as we have observed, and the resumable full load feature. This is something that we have not explored as of now, but this will come in handy when we are ingesting a big data set, or we are performing a full load on a very large data set. And if for some reason, for memory issues or any other reason, it fails, then we can actually resume it from the point where it failed. Whereas in Debezium, we'll have to do the whole thing again, right? Partitioning is something that I think we have already seen and discussed. Priyansh has already shown you the demo of partitioning on Iceberg. So this is something cool that we'll have in OLake out of the box, and we'll not have to take care of that uh, in our downstream consumers. So this is something that I really liked about OLake, and the features that we have used in Physics Wala. Right. So moving on, we'll have demo section. So obviously, I cannot show you the exact cons that we are using because of the keys and all, but I've put it in the slide just for your reference of how we are using it. And this is something that Priyansh has already displayed earlier. So we are breaking it down in three parts. So one is writer config, one is source, and the last one is catalog. So writer is you can map it to destination thing. So how we map it to destination, we are using the catalog type as Hive. So Hive for Hive Metastore. Normalization is true that I've already discussed that it will cater all the schema changes and bring in data with the schema. We'll have to pass in the warehouse path of Iceberg, then Metastore URI that we have, then access keys or secret keys that can pick it up from IAM roles as well. But just for the simplicity, I've put these properties here. Then some SSL and path related other properties that we have a very good, I think, documentation in place. We can go through all these properties. The main things that I can discuss is that Iceberg DB. We'll have to just mention the DB name, uh, Metastore URI, Iceberg path, normalization, catalog. So these are the main properties that we can focus on. Then we have the source config. We'll have to pass in the information regarding the source that we have, like let's say in our case, it's Mongo. So the host of Mongo, username, password, or DB. Read preference would be like, let's say we just want to read it from secondary. If it is a SRV string or not, then we can put SRV as true. Then server RAM and all, if we want to define it here, but I guess if we are deploying it on Kubernetes, we can have a for template where we can define the resource limit and guarantee, right? The max thread, so this is something that is actually useful in chunking the data. If we have a lot of records in a particular collection, we can increase the threads for faster loads. I'll keep it as two because I'll be demonstrating a small dataset load that only has around 50 lakhs record. Then we have default mode as full refresh CDC, but we'll put it as CDC. Then this is the retry count. In the catalog conf, like this is also something that Priyash have already displayed earlier. So uh, just to make it simple, so we'll have to pass in the collection that we want to be ingested. So this comes inside the selected stream part. Then this in this stream part, all the metadata regarding this collection will come. So if you see in the selected streams, I say that this is the DB name, PW community 2, and then some information regarding the partition and all, how will you want to see the data in Iceberg, and then the collection name. So this is the likes. Then in stream part again, we'll have some metadata regarding the collection that we have. So I think Priyansh has already walked you through all these things that we have in stream part. So, and one fun part is that you can generate this catalog part using a command that OLake provides. So we do not have to write this thing. This may seem a little bit complex, but we don't have to write it anyways. Yep. So now the demo time. So I'll be using staging collection that we have. So this is the collection that I'll be loading into our Iceberg warehouse. So this is the likes collection. We have around 15 lakhs records inside this collection. If you want to see how the data looks like. So, okay, I think we have to log in again or okay. So this is how our data looks like. So the thing sensitive, we can go over it. So lots of IDs and the name. So this is all the data is about. So we can see only like in the few records, the post ID created, updated at in user, it's an object with name and ID. But I know there are more keys in this, so that we can see when once we have ingested this data into our Iceberg. So we'll actually see the schema evolution in place as well. So I'll be using the configs that I've just displayed, and we'll be doing it on again Kubernetes. So this lens that I'm using the UI tool for Kubernetes. So we have already set up these three writer configs. Obviously, I cannot show it because of the keys and all. So writer config that we have already discussed, I've shown you what is the formats, and I'm just keeping the same thing here. Then source config, then catalog config. So all these things are set up here. And then we have to create a cron job. So cron job is created here, and just run this cron job. We'll see. Okay, it's maybe locked out. Just reconnect the clusters. Okay. Cron job. Great. So it came up here. So it will take some time to launch the pods and pull the image of OLake. So it may take a minute or two. It is finding the node to schedule it on. I think we have the node. Volume is attached. Okay, so the init container is running right now. Then after this, we'll have the actual container running. Great. So it is pulling the OLake image now. Yeah, I think it got succeeded. Let me just check on the OLake folder. So we have the like still. We just check the record count that we have. Mm, So in the likes, we have around 1507610 records. So around 15 lakhs record that we have in likes. Check it out here. Okay, so we have the 15 lakhs that we needed. If you see the data, yep, the data is replicated as it is. So as I've mentioned that initially we like for the first few record we have only seen the user post ID created and updated at in the table, but for some record it may have comment ID and reply ID as well. So these columns are added and like maybe for these records we have null comment ID and reply ID, but uh, during the full load it gets automatically added and we'll just have to uh, see if any schema evaluation is doesn't happen here. So let me check if we have any comment ID is not null. Sorry. Schema like okay, I'm running it on prod. I'm sorry. Yep. So we can see, yeah, so these comment IDs are here and our schema evolution is working as expected. So, yep, I think that is it that I wanted to share. Maybe Priyansh, Shivam, you can take over from here.